Well, thank you so much for that introduction, and it's great to be here to present and share this information. It's a personal passion of mine. I love RF, and this technology really fascinates me. So I've really studied it, tried to learn a lot about it. Again, my name is Dr. Wes Moore, and I'm with a company called Accutech, and we want to talk today about Public Safety BDA. Public Safety BDA, emergency responder coverage enhancement systems. So let's get started. Let's work through a roadmap here. What do we want to talk about? First of all, we want to ask, what is a public safety BDA? What is an ERC system? There are different names for this. We'll hit on that in just a moment. What is it? And then how does it work? We're going to have some images and some illustrations to show you how all these pieces come together and what this thing does and how it works. And then we want to ask, when are they needed? When do I need to consider this for my building? What do I need to do if I do need to consider this for my building? And then finally, we want to talk about estimates, estimating testing costs, estimating budgets, construction issues like conduit and electrical service. And then I've got a master spec template specification that I want to share with you at the end. That'll be in a Dropbox link that we share. I developed one of those for you to use. So again, as Taylor said, in terms of questions, if you'll put those in the Q&A tab at the bottom of the screen, that would be great. We'll go through all the content, and then we'll talk about questions at the end. So then, what is a public safety BDA? What is a public safety BDA? All of this goes back to 9/11, actually, when the first responders were trying to get into the towers, the Twin Towers. They found that the radio systems they were using inside the building to get outside the building weren't working. So they weren't able to communicate with the teams outside. So you'd have teams of firemen, for example, going through floors and clearing them, but not being able to communicate with the other teams, whether they're in or outside of the building. And so we had multiple teams clearing multiple floors and all kinds of other life safety issues that arose from this failure of the wireless communication system inside the commercial building. And so this started sort of a move in the industry to remedy that. And that's what we have today when we talk about a public safety BDA or an ERC system, or whatever term that you want to use. So essentially, a public safety BDA is a wireless system that allows the first responders inside the building to communicate with other first responders in the building and to communicate with first responders on the outside in an emergency. That's essentially all this is. It's a wireless system to help with the radios of the first responders, and essentially assuring and ensuring two-way communication in and out of the building for those who need to do that. Now, this goes by many names, as we've already mentioned. We've got Public Safety BDA. Now, that's typically what I hear. I'm in South Carolina, and generally when we talk about this in our industry down here, we'll talk about the BDA, the Public Safety BDA. But there's also the standards and codes refer to this as ERCs, which is Emergency Responder Coverage Enhancement Systems. You'll also see it called Emergency Responder Radio Coverage System, and PS-DAS, or Public Safety DAS. So all of these terms are referring to this system in a building to ensure two-way communication for first responders, whatever the term is. So what does BDA mean? We won't go into a lot of technical detail in this presentation. It's designed for a general audience. But BDA means bidirectional amplifier. It is an amplifier. Think about an amplifier in a car radio, but it's taking the signal that's coming in from the outside and it's amplifying it on the inside. It's taking the signal on the inside and it's amplifying it to the outside, which is essentially what the BDA system is. It's a central component, kind of the core piece of this public safety BDA is the antenna or the amplifier itself, amplifying the wireless signals going in and out. It's the heart of the system. Now let's hit on codes here just for a moment. And I'll emphasize that I'm in South Carolina And I'm going to talk about from a code standpoint, I'm going to talk about this from a South Carolina perspective. If you're in North Carolina or Georgia or anywhere else, you may have different codes that apply, and you'll need to consult your AHJ to figure out what those are. But as a basis of our discussion, we're going to talk about South Carolina. Now, South Carolina has adopted the International Fire Code and basically made some changes to it. IFC 2021 made some changes to it and put it out as their own fire code. In that, the IFC 2021 refers to two specific codes that deal with Public Safety BDA. That's the NFPA 1221 and the NFPA 1225. Now, not to confuse you, but essentially, these are in the IFC 2021, it will reference these two sections for Public Safety BDA. And so when you're talking about what the codes are for Public Safety BDA, you really have to look at the NFPA 1221 and 1225. Now, the 1225 is an update of the 1221. And what we're finding in South Carolina is that some AHJs, because the code itself still refers just to 1221, the South Carolina State Code has not adopted formally the 1225. They'll still use the 1221 as their basis, but other AHJs will use the 1225. So you have a little bit of a mixture. Don't let that confuse you. I'm just trying to give you the information about what codes are in play. So the 1225 is primarily what we'll talk about here because it does improve and incorporate 1221. Now, because we are also going to connect this system to the fire alarm, a code that's relevant is the NFPA 72, which is a fire alarm code. And then because we're dealing with a radio system, there are various FCC parts of their code that apply as well. Now, we're not going to go into detail on those, but I just want to make you aware of the codes that apply in this industry. Now, let's get into how they work. So we know in a big picture sense of what we're trying to do, we've got a two-way radio. We're trying to communicate back and forth inside and outside of a building. But how does that happen? How does that work? All right. So the big picture here is we've got a dispatch. So all is going to start with your dispatch. You call 911, and there's a fire or there's some kind of an emergency. Well, in every county of or city of, they're going to have these antennas that are dispersed around the county or the city that the dispatcher is going to call out on through a two-way wireless radio system to talk to all of the various first responders. We've got fire, we've got police, we've got ambulance, and maybe others that they're trying to talk to. Those units have in them these two-way wireless communication system that communicates with the two-way tower. But then you've also got the individuals that have the little radios on their person that they're talking. You've seen that on TV with police or with fire. And so you've got this whole network here of two-way radio communication that's going on in every county of and city of. And this is known in the big picture as a land mobile radio system, an LMR, a land mobile radio. So let's take this example here that we've got an emergency. And you've got a fireman who has to go into a building that's burning. All right. What happens is when you take a wireless radio inside a building, it doesn't always, the radio signal from the outside doesn't always come inside. The materials within the building and other factors, the type of windows, can basically just cut the signal off completely. So what happens is you don't have any communication inside the building with those who are outside of the building. And that's a problem. So what a public safety BDA does is it creates an antenna system on the outside coming inside that then allows you to communicate from the inside out. That's really the role of a public safety BDA. Now, how is this done in terms of components? In the big picture, we have two major pieces that we're mounting on a wall somewhere. We have that amplifier we're talking about, bringing signal in and taking it out. And then we have a battery backup. So if power goes out, this system stays up. And generally 24 hours, depending on the draw and the size of the battery, but it varies, 12 to 24 hours, depending on the unit and the code. So what we have is we have this amplifier on a wall somewhere, and we're going to go out with coaxial cable, half-inch coax, And we're going to start talking to and connecting to antennas. So first we're going to the outdoor antenna. This is called the donor antenna. This is mounted outside the building, on the building somewhere, pointing at whatever tower that we're trying to reach. And then on the inside, we have indoor antennas that are distributed around, just kind of like a wireless access point, if you will, for this system. So that wherever the first responder is, they can get to that antenna and then get out to the donor and then get out to the tower that's connected to everyone. So that's the big picture components. We'll dive into this a little bit more in a moment. Now, key manufacturers, there's no sales in this whatsoever, but just to make you aware of some of the names in the industry, I've gotten that question when I do this presentation sometimes. But your big players in this would be Kumba, Westel, ADRF, Fiplex, which is a Honeywell. There are others, but these are your big players. Now let's look kind of at an image here to help us see some of these components, and we'll drill down and have some pictures that help us get closer to these as we move on. But this is a system that's mounted to a wall. All right, here we've got the amplifier up here in the top left. That's what is doing all the work. We've got our battery backup down here in the bottom. We've got our donor antenna up here to the left. That's outside of the building. And then we've got our indoor antenna here inside the building itself. Looks like that plate. You're familiar with seeing those in the ceiling. We have an annunciator panel. This is a panel that's basically going to show us what's working and what's not. If there's a problem, a first responder can go right up to that and see with blinking lights, this is working, this is working, this is a problem. Then we have connection points to the fire alarm. We connect this system to a fire alarm so that if there's a problem, it goes to the fire alarm system and notifies someone that there's an issue. We have documents and test data, essentially test data. So what happens is when you finish one of these and you install it and it passes, you put your passing test results in here so that this system is required to be just like a fire. It's required to be tested every year. So all the documents go in there with all the test results, and that becomes the basis for evaluating the system the next year. So that's important to have that there. Coaxial cable splitters. Remember, we're running coax out, and then a grounding bar. So those are the big picture components. Now, different manufacturers make things differently, and different installers put things up differently. But this is a big picture image of how all of that would go together. Now, here's a little bit of a zoom in here, showing you the donor, interior, amplifier, test results, and the annunciator. So you can see a little bit more clearly there what those look like. Now, if we go on down here, we're going to take a quick peek at the battery backup. We see we have our batteries in here, and then we have our fire panel connections there on the right. This is the annunciator panel, kind of showing you a little bit closer view of that. The code requires 6 different things be constantly monitored. Obviously, in an emergency, we want everything to work. Not going to go through, again, the purpose of the presentation is not to get that granular, but things like power, if the charging is working, if there's antenna failure, these are the things that we need to know so we can keep this up in the case of an emergency. And a final picture here. We have these 4x4 boxes that we're using in this case to connect all of these different components to our fire alarm. Now, the code doesn't require, I've got a note here, the code doesn't require 6 boxes. It only requires 6 connections. So there are various ways to do this, but this just illustrates how this works. Now, down here at the bottom right, under that logo, you can see a kill switch, to power kill switch. That is not required by the code. It's optional. It depends on the AHJ down here in the Charleston, South Carolina area. According to the guys that I work with, the local integrator partners, they don't require that. They haven't seen that required here, but it may be different in your jurisdiction, in your area. Okay, so we know why we're doing what we're doing. We know the problem that we're trying to solve. We know the big picture components, and we've kind of seen how all of these things lay out on a wall, and we understand how things are working. So let's transition now, and let's talk about when we need one. All right, so you say, Wes, we're going to build a building. How do I know that we'll need one? And if we do need one, what do we do? All right, so let's transition into that. When are BDAs required? And again, I'm going to talk to you about South Carolina, and your local AHJs and codes may be different. So just remember that as we go through this. All right, in South Carolina, essentially any new building, anytime basically when you have to pull a permit to build something, and certainly in the context of what we're talking about with healthcare, these are usually pretty good sized buildings anyway. If you're pulling a permit, you have to at least test to see what the signal strength is inside the building. Now, you don't always have to have a system installed, but you do always have to test to see if you need one. And so what this is going to do, we'll go through testing here in just a moment. It's going to determine if the signal level inside the building is sufficient for the two-way radio to work properly, for the guy or gal inside the building to be able to hear and communicate. All right. So you always have to do the testing to determine if the signal level is sufficient. This tells you if you need a system. Okay. If everything passes, you won't need one. You'll submit those reports to the AHJ and they'll be, will be good to go. Nothing required. If you do need one, it will tell you where you need it. Sometimes a whole building is just dead. Every corner of that building just doesn't pass, okay? But many times what you'll find is the area that's near where the tower is, that side of the building may be strong and the opposite side is weak. You may find on the outside of a building, you're good. As you get inside, is where you need the BDA. If you've ever had your cell phone and you walk over to a window to get coverage, it's a different frequency, but it's the same basic principle. All right. So you test to determine if you need one and where you need one. Now let's talk about testing levels. I'll mention at the end of the presentation that I have other versions of this presentation that I do for general contractors and for engineers and consultants or owners that want to know more details about what the tests are, how they work, what the levels mean, and all that kind of stuff. But for right now, I'm going to hit the big picture so that we can just move through this quickly. But essentially, the test levels, if the radio signal falls below a certain level, and the 1225 mentions two types of tests, what's called the RSSI test, which is a signal strength test relative to the tower that you're going to. All right, how much signal loss do we have inside the building relative to the tower power, and something called a DAC test, which is also measured by electrical parameters, but it tends to focus on whether or not we have a type of sound that we can hear. Is it audible and clear when I'm talking? What they found is sometimes signal level readings, like the bars on your phone, you may find this even on your phone. Sometimes those readings will be high enough, but you don't necessarily have good audio quality. And vice versa. Sometimes they've found that if you go into a building and it says, hey, the signal strength is too low, the AHJ pops his radio out and he starts talking and everybody can hear him. All right, so there's some movement towards the DAC test and movement away from the RSSI test. Again, we can talk later if you need more information on that. But basically, there are two types of tests in the system. All right. And what it requires is that the coverage for these tests, 90% of the entire building has to have sufficient coverage based on these tests, whichever one you're using. All right. And 99% of critical areas. So basically areas where people are going to try and get out or where first responders are going to be doing what they need to do. So the critical areas are things like the fire command center, elevator lobbies, stairwells, basements, exit passageways, and sprinkler or pump rooms. Those are like, hey, we got to have coverage in virtually every corner of those critical areas, but we don't necessarily have to have it for every single inch of the building. Now, in terms of how these levels are measured, you say, okay, Wes, we understand we've got to do testing, and we understand the types of tests and so on. So how do we actually get these tests done? How do we know these numbers? Well, there is something called a grid test that's accomplished. There is a specialized piece of equipment. You can see it here in this little image on the back of this gentleman here, kind of hanging off the shoulder like a backpack. There is a piece of equipment that they walk around the building. They break the building up into grids. So they'll cut it up into little squares, and they will go to each square and they'll run these numbers, the RSSI test, the DAC test, and that will give them numbers. And those numbers will be logged into the software. It's very specialized software that's used here. And at the end, it will produce a report on the grid telling you where you passed and where you failed. All right, so it's a grid test. And you have to pay someone to do this. As I said, you've got signal strength and the delivered audio quality, or the DAC test. Now, this is an actual image of a report from one of these tests in a building here in the South Carolina area. And so you can see here, and again, it's probably, you won't see the detail here, but you can see the grids. If you look, you'll see the red lines going horizontally and vertically. You'll see the little circles in the middle of those grids. Those are giving you numbers. In this case, this is the RSSI number. And then you can see green or red in those grids. Well, the green is good. So the green means you passed. And you can kind of see in this building, you've got the outside primarily that is showing that it's passing. And the red is bad. That's where you failed. And so those are the areas where you have to put your antennas to get that signal strength up so it passes in the final before you get your CO. All right. So when you get somebody to do a test, all of this is going to be part of the testing. You'll get all of this information, and that will be the basis for you determining what you're going to do and where you need to do it. So let's move now and let's talk about estimating costs, when to test, and some specifications for you. All right, how do we estimate this? You say, Wes, we don't know we're going to need one, but I've got a building to build here. I've got capital money I've got to lay out. Where do I put this, and how much do I use? All right, so first of all, as we said, you can't be sure you're going to need it or how much you're going to need until the building is completed. All right, walls are up and everything is functioning. So what do you do in the meantime, in the planning process? All right, first of all, you got to budget for testing. No matter what you do, as a rule, you're going to have to test. You're not going to get a CO without testing for this. In South Carolina, that is. Again, with other jurisdictions maybe being different. All right. What we're finding is $1,000 to $4,000 for testing charges, depending on the size and the type of the building. Okay. You will need to test no matter what. Now, the budget for the full coverage, if you're saying, okay, I need a set aside, or I need a number, a placeholder in my budget in case we have to do this. What we're finding is 40 to 80 cents a square foot. That includes parts and labor for the areas that you will need to cover. Now, generally what we see done is folks will say, okay, I got 100,000 square feet. I'm just going to assume that I'll have to do it all. All right, so I'm going to use 100,000 square feet. And then if it's an open warehouse, it'll be towards the bottom of that number, because you just, if you've got a tilt up wall kind of building that you're just going to lease, everything's empty, then 40 cents will cover that. If you've got something where you've got a lot of walls, you've got a lot of low E glass, you've got a lot of equipment inside, then you're going to need to go to the higher end of that. One GC told me recently he puts in $1. Okay, that's what he does. The number that we recommend is 40 cents to 80 cents, depending on what kind of building you have. Okay, so those are the kind of numbers that you can use as you're budgeting. Now, when do we test? When are we going to test? Obviously, we can't wait till the day before the CO to test. Okay, that's when you probably have your best number ever, when everything is all done. So we can't wait that long. So recommended time to test is in dry in. The first test you're going to do to see what you need, the one that's going to produce that picture with the red squares and the green squares, is when the doors are in, the windows are in, exterior surfaces are up. Basically, when you can lock the building or you're very close to locking the building. Now, someone asked me once about drop ceiling. So we need to wait till the ceilings are in. You generally don't have time to do that. Yes, that will affect the propagation slightly, but with a trained integrator who knows RF and knows that area and does this test, they'll be able to tell you based on that initial test. Yeah, regardless of what you do with your ceilings, you're going to need one, or vice versa. Okay, they can tell you won't need one. So you're going to grid test inside. You're going to test on all 4 outside areas, all 4 sides of the building, and on the roof. You're going to get those numbers. And a trained tester, someone who does this for a living, will know that and be able to do all of that for you. That test will tell you, okay, we need one, and these are the areas that we need it. So then you design it. Usually the installer will design it for you with the help of the manufacturer. We help with that as well. And then they will put it in. And then sometime before you're going to have your AHJ come in, you want to do that second test, which is a part of the testing cost to start with. Everyone knows you've got to test it again to see if everything passes, if there's some tweaks need to be made or whatever. Okay. And then you bring your AHJ. One of the installers that I work with here said he tries to have that second test 5 to 7 days before the AHJ is going to come visit in case he needs to change anything. So we're doing the test at dry in to see if we need it. We put it in, we test it a week, give or take, before the AHJ comes to do his final inspection. Now, what we're finding here in the Charleston area is not every AHJ wants to come for the sake of BDA, needs to come to the site and says, I've got to come and test my test my radio. Some of them will just let you submit the reports, and some of them, there's one here in North Charleston, for example, he likes to come out and he wants to physically be on site and be able to test his radio to make sure that it works. So that's when to do the testing, and that's recommendations for how this is going to play out. Construction needs, not tons to say here, but there is some stuff that we need to talk about. Conduit. All right. We can go into all kinds of discussions about conduit. Essentially, sometimes the AHJ will require some portions of it to be in conduit, the cable, and sometimes they don't. It varies by the AHJ, so I can't give you a hard and fast there. This is where your relationship with that local RF integrator is going to be helpful. And I'll mention more about that in just a moment, because he or she will know what, this county, they asked for this county, they asked for this, and so on. You need a 120 volt outlet for the head end equipment. That's the amplifier. You need one dedicated circuit for each amplifier. So sometimes in a larger building, you'll have an amplifier, on one end, and then you have to put one on the other. And so you'll have to have power for both of those units if you have more than one. And then, as we saw in our images before, you'll need a grounding bar and wiring to building ground to ground everything. Roof penetrations are also an issue. Sometimes you can go out the side of the building and just go up and mount it on the side, but a lot of times you're going through the roof. So you're going to need to get through that to install the antenna mast. Most systems need just a 1-inch conduit, but your integrator will be able to tell you what he needs. And then you'll need to ground that as well. So from a GC standpoint, you'll need your roof guide. Generally, these integrators don't want to poke through a roof. So you'll need to get them to, kind of tell you what they want. And you'll need to get your roof guy to give you a number to do that. Now, in terms of construction needs, again, we're talking about fire rated plywood. Usually 4x8 is needed. I know we all want to keep, reduce the space, but when you've got all these pieces of equipment to mount, it generally takes up that entire sheet, and the contractor can help you determine where, you need that. And then you'll need a number from your fire alarm contractor to connect to that fire panel. So you'll need that. Now, the final thing I want to mention here is something about 2-hour enclosures. A lot of discussion about 2-hour enclosures when it comes to these systems. This language has to do with essentially the fire rating of the devices themselves, the BDA, the amplifier, the battery backup, and the cabling. Because obviously, if you have an emergency and we have a fire, we need this stuff to last, or we want it to last as long as possible so we can continue to communicate. So it has to do with survivability and an emergency. Now, there is a lot of confusion about this, and the reason the confusion exists is because you've got so many AHJs with different views of what they want. You've got the 1221 standard, which has one thing to say about it, and the 1225 changes it. So there's a lot of different information floating around. Now, I read and verified this morning in the NFPA 1225 regarding this piece. So I'm just going to go through just briefly what it says. And if you need to talk later about it, if you need a copy of that NFPA or whatever, I can get it to you and to get you clarification. But essentially what it says here is, if you have a building with a full sprinkler, building that's fully protected by an automatic sprinkler system, no fire resistance rating is required for the cables or the enclosures. So if everything's 100% covered by a sprinkler, you don't have to worry about an hour rating for this system, okay? But if you don't, and I'm not a sprinkler expert, but I would think that most buildings don't have that kind of coverage, then says if you don't have a sprinkler at all, if you only have a partial sprinkler system, or if you're in a high-rise building, then if the primary structural frame of the building is 2-hour rated, then the equipment and pieces of that cabling system, backbone cabling, mostly to the donor antenna, need to be 2-hour rated, okay? If the primary structural frame rating is less than 2 hours, then it needs to be a 1-hour rating for this system. And if there's no rating for the structural frame of the building, and I'm not a structural guy, so I'm passing information along, then no rating is required, okay? I'm going to just kind of leave it there and deal with other questions that you might have on a one-on-one basis or as they come up, because it is a confusing thing and you get various people telling you various different things. Now, let me kind of bring this all together here. So you've got all these different types of tests. You've got the grid, you've got different AHJs, you've got different codes, you've got different county RF, people who you're dealing with. You say, Wes, this is just a lot. All right, no problem. I understand that completely. So how you need to think about this is get someone in that area, a local RF integrator who does this all the time with experience in BDAs and experience dealing with these local county ofs and cities of, and they can give you the test. They can say, okay, you're going to need this test. This AHJ is going to require this. They're going to require conduit here. They're going to require this rating. Okay, so, this is how much, these are the things you need to include as you're trying to budget this and do this. Because there's really going to be no other way for you to know that unless you're dealing yourself with the AHJs, every day on this kind of thing. So the easy button is, let's find an expert in that area to help us do this and figure this out. Now, I can help you with that. We have relationships with these. We kind of have an ecosystem within the BDA world in our offices all over the country. So we can get you in contact with those local partners who can do all of this for you. I've got my email here, which will be up a little bit later as well. If you email me and say we're in this county of, and we need somebody to do a test, we can give you names. We can give you multiple names of good qualified people. All right. And then lastly here, I wrote a template specification for Public Safety BDA in the master spec format. I was working with an engineering firm, and we were looking at their master spec section here, and it was, to be kind, it was not sufficient. So what I did was I worked with some of our ecosystem partners, and I came up with a specification that gives you everything that you need in a template. Now we've got that, and it's in the master spec format. There should be a link in the Dropbox file for this in the chat of this presentation. If you don't get it today and you need it later, then you can email me and I'll email you a copy of it. We've got several different versions depending on how you want to specify it, or you want a basis of design, or you want, 3 or 4 guys listed, or however you want to do that from a manufacturer standpoint. We've got that. All right. And again, I'm almost finished here, but I will mention to you, I've got this master spec specification that I can help you with. I can help you get with your local RF integrator if you need someone to do testing or install, but also I can do training for you. Essentially what I've done here is I've taken the training that I do for general contractors and engineering firms. So I've got 2 different versions of this. And for today, I've kind of condensed it and pulled out some of the detail for what we're doing here today. But if you're a general contractor and you want your team to be trained on this in a more detailed way, I do lunch and learn 101s on this all the time. Or if you're an engineer or consultant or even an owner, and you want to get up to speed and you want to talk maybe more detail about the electricals and about some of the testing and the frequencies and Class A versus Class B and so on, then I can help you with that as well in terms of training your team. So we're really here as a resource for you from a technical standpoint.